What's up? I'm Vin, and I'm going through the 2024 Grade 8 math test from New York. And for this test, we get to use a calculator for both sessions, a scientific calculator. I'll leave a link to a copy of this test in the description below. Now let's get started. Question 1, a group of friends went to a movie theater and paid $15 for each movie ticket. The group of friends shared one container of popcorn that cost $8.99. Which equation can be used to determine the total cost C for N tickets and the container of popcorn? So for this question, what we need to know is the formula y equals mx plus b. This is the equation of a line formula. But in situations like this, when we have a word problem, we have to know what each of these pieces mean. So here, this represents the total cost. Okay, so the y is the total cost. M, the slope of the line, is the rate of change. Okay, so this is the rate of change. And then x just represents the independent variable, and this represents the thing that you are buying. So in this case, we're talking about tickets, and the tickets are $15 each. So x would represent tickets, and then b is the fixed amount. The y-intercept in word problems is the fixed amount. Now, the only thing we have to be on the lookout for here is that instead of x and y, they used n and c. So here, let's just think about what each piece means. The total cost C would go in place of y. So we'd have C equals, M is the rate of change, and we look through the question again and see that the $15 price for each movie ticket, that's the rate. That's how much money the group of friends is paying for each movie ticket. So we're going to have 15 times the number of tickets is N, so that's going to go in place of X, and then the fixed amount was that the group of friends shared a container of popcorn that cost $8.99. So they're only buying one, so this is going to represent the fixed cost. So the $8.99 is going to go after like this. And now we just scan the answer choices, and let's see. C equals, we have 15N plus $8.99. Choice A is our answer. The problem with choice B is that the $8.99 is attached to the variable, but that's not the rate of change. That's the fixed amount. So that's why this one is no good. Here, we're not distributing the 15. The 15 is only attached to the price of the ticket. If they said each friend is buying a container of popcorn, then we would distribute, but that's not the case here. Okay, and then for this one, this is just way off. The price of the popcorn is $8.99. We wouldn't multiply that by the number of tickets. So that's way off. Choice A is our answer. Question 2, a scatter plot is shown below, and we want to know which pair of points could be used to draw a line that best represents the relationship of the data. So for questions like this, what I like to do is just sketch a line that you think would go nicely through these set of points. So here, I'm just going to draw this line in, and we could see that this is going to capture the data that's represented here in the graph. Now, one thing to be on the lookout for is that when you're drawing a line of best fit, you have to draw the line so that it tends towards most of the points. Like I wouldn't draw something crazy like this where it's just downward sloping like this, where it's going through a few points, but it's clearly missing the majority of the points. So that's what we have to keep in mind as we go through the answer choices, is that we want a pair of points that's going to be on the line of best fit or close enough. So let's see, something like 4, 7, and 8, 4. So 4, 7 is over here, and 8, 4 is over here. But the problem with connecting these two lines is that this would be a negative sloping line, which wouldn't capture the majority of the points here. So A is out. Now we look at 3, 3 is here, and 9, 7 is over here. And if we were to connect these 2 points, this is looking pretty good, okay? So right now, I'm going to leave this one as a contender. And now let's look at the other answer choices. So 2, 4 is over here. So we have 2, 4, and 6, 4. The problem with connecting these 2 points, if we connect these 2 points and make a horizontal line, it's going to miss the majority of the points. Remember, we need a line that has a positive slope. And if we have a line like this, that would give us a line with a 0 slope. Okay, so C is out. This one is definitely no good. And then 3, 2 is over here, and 3, 4 is up here. So this one is no good because if we connect 3, 2, and 3, 4, that's going to make a vertical line, which is going to miss the majority of the points. So D is definitely no good. So B is our best answer, and that's our solution to question 2. Question 4, triangle ABC is rotated 90 degrees about the origin and then reflected over the y-axis to form triangle A prime, B prime, C prime. one of the angles in triangle ABC has a measure of 115 degrees, and one of the angles in triangle A prime, B prime, C prime has a measure of 40 degrees. Which is the measure of an angle in triangle ABC? So for this question, what I would do is just draw something out. They are telling us that one of the angles in triangle ABC has a measure of 115 degrees. So I'm going to draw something that's a little bit more than a right angle. So we'll say this is our triangle over here. Okay, I don't have to make this an isosceles triangle. The less symmetry here, the better. But remember, this is just something to help us visualize what's going on. So even if I made this isosceles, it wouldn't matter. I don't have to draw this to scale. So I have my 115 degree angle, and they're telling us that the triangle is rotated and then reflected. Now, I don't actually have to start spinning this or flipping it. Just know that when you rotate and you reflect, that these are what we call rigid motions, that the resulting triangle is going to be the exact same size and shape as the original. Okay, so I could say that triangle ABC and triangle A prime, B prime, C prime are the exact same shape and size. The fancy word for it is congruent. The two triangles are congruent, but just know that these two triangles are going to be identical twins. So if one of the angles of A prime, B prime, C prime is 40 degrees, that means one of the angles of the original triangle is also 40 degrees. So now we have a triangle where we have two of the angles and we want to find the third angle. So what we could do is we could add up the three angles. So I'm going to go x plus 115, and I'll leave the units out for now. I'll just tack it on at the end when we talk about the actual answer choice. But the sum of the three angles inside of any triangle is going to make 180 degrees. So now I'm just going to write the result over here. We're going to have x plus, and if I do 115 plus 40, that's going to make 155. If you don't feel like doing that math by hand, you do get a scientific calculator for the whole test, so there's no shame in it. Use the calculator. And now to solve for x, to get rid of plus 155, I do minus 155. And same thing. Here, if you want to just type this in a calculator, you can. I'll go ahead and do the long subtraction here. So I borrow from the tens place, make this a 7. Doing 10 minus 5 is 5. 7 minus 5 is 2. So x, the missing angle here, is going to be 25 degrees. Okay, so the other angle is 25 degrees. So A is definitely our answer. The problem with the other answer choices is that if I have 115 and 40, the third angle has to be 25. So a 75 degree angle is impossible. A 155 degree angle is also not possible. And a 180 degree angle would never be possible inside of a triangle because the three angles have to make 180 total. So if one of the angles is 180, there's no way to close a triangle. So A is definitely our answer. Question 5, what is the value of x in the equation given here? So for this question here, we're going to have to just do the algebra. So what we want to do is we want to get all of the x terms on one side, and we want to get all of the constant terms on the other side. So with this question, we could start off by just doing plus 7 on both sides. And that's going to give us, let's see, we have minus 7 plus 7 canceling. And now on the left side, we have 2/3 x equals 5 plus 7 is 12. And then we have minus 3/5 x. And from here, there's a few ways we could handle this. But one thing we could do right away is just add 3/5 x to both sides. So I'm going to go plus 3 over 5x on the right side. And then if I do that to the right side, I have to do the same thing on the left side. So I'm doing this. So now we get here, and for this part, it might be a little bit tricky, but we're just going to use our fraction skills. If it was something easy, like let's say 2x plus 3x, for something like this, we just do 2 plus 3 is 5, and the x just tags along. So here, what we have to be able to do is add 2/3 plus 3/5. So for this one, what I'll do is find common denominators. The common denominator we want is 15. To make a denominator of 15, I'm going to multiply the first denominator here by 5, and then I have to do the same thing to the numerator. And then for the second fraction, to make this a denominator of 15, I have to multiply by 3, so I'm going to do the same thing up top. And now we have 5 times 2 is 10 over 15, plus 3 times 3 is 9 over 5 times 3 is 15. So now 10 plus 9 is 19, and we're over 15. So here, that gives us 19 over 15x. I'll just make that a little bit neater. So 19 over 15 times x equals 12. And now from here, to get rid of the 19 over 15 in front of the x, the 19 over 15 is attached by multiplication. And the opposite of multiplying by 19 over 15 is dividing by 19 over 15. So that's what we're going to do to both sides. We're going to divide both sides by 19 over 15. And now these terms will cancel out, and we're going to have x equals, and the technique that I want to use here is keep, change, flip. I keep the numerator, so I'm keeping the 12. So I'm going to do 12. I change the operation from division to multiplication. So we're doing 12 times, and then we flip the bottom fraction here to 15 over 19. And now from here, we're just going to work this out. We could use a calculator. So I'm just going to do 12 times, and then we have 15 over 19. So we're doing 15 and then over 19 like this. I'm just going to put that in parentheses. So what we have here is 9.4736, blah, 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 blah. So the answer is going to be 9 and change. And the only one that has a leading 9 is choice B. And if you just want to double check to see if the decimal after the 9 matches, just type in 9 divided by 19. And this will tell you here. You see how we have 4736, 842, 105. So this matches what we have above. So choice B is looking good. If you wanted to do this more by hand, what you would do is you would do 12 times 15. So 12 times 15. And then here we have 180 divided by 19. But if we do 180 divided by 19, we're going to see, we're going to get the same answer for now. But watch what happens if we do 19 times 9. 19 times 9 gets us to 171, and that gives us a remainder of 9. If I did 180 minus 171, you could see that we were 9 away. So that's where that numerator of 9 is coming from, the 9 and 9/19. But either way here, we're getting choice B. So our solution here is choice B. If you want to show the work so that it leads to this exact mixed number, once again, what you could do is 12 times 15 we said was 180. And if we do 180 divided by 19, we saw that we could get as close as 19 times 9. And 19 times 9 was 171. And when we subtract 180 minus 171, we get 9. That's our remainder, and it goes over our original divisor. So choice B is definitely our answer. Question 7, two electricians, electrician A and electrician B, offer pricing plans for their work. Each electrician charges an initial fee for a service call plus an hourly rate. The charges for each electrician are represented by the equation and the table shown below. And we want to know which statement comparing the charges for each electrician is true. So here, once again, we're going to be using this formula, y equals mx plus b. And in the context of this word problem, m is the rate of change, and what we have here, we're going to call m the hourly rate. Okay, so this is the hourly rate in the context of this word problem. But remember, in general, y equals mx plus b, m is the slope, but in word problems, that's the rate of change, and b is the fixed amount. But what we look for here in this question, b is the initial fee. So the fixed amount, we could also just call here the initial fee. So now let's go ahead and extract the information for each electrician. So for electrician A, their hourly rate is much easier to spot because their equation is expressed in the form mx plus b. So their hourly rate is $25 an hour. Okay, so $25 an hour. And their initial fee, so I'll just say here, their initial fee is going to be $50. Okay, so this is for electrician A. Now, electrician B, them, it's a little bit more complicated, but we just have to look for what we see in the table. So notice as the time goes up by 1, we're counting by 1s going 3, 4, 5. Let's think about what are we skipping by to get from here to here? Well, to get from 130 to 150, that's going up 20. So that's plus 20. And the time is going up by 1. So that tells us the hourly rate is $20 per hour. So for electrician B, I'll just say here the rate is $20 per, it's $20 an hour. So the initial fee, so the initial here, we just have to go back to what would it be at time 0. Because notice here, if I were to plug in x equals 0, x equals 0 tells us how much you're just going to pay for the service call. So if I did 25 times 0 plus 50, see how that gives me the 50 over here. 25 times 0 is 0, and that gives us a charge of $50. So we basically, for this, I would just say go backwards. We want to go backwards to times 0. So we're running out of space, so I'll write this over here for electrician B. I'll make the column like this. And if I go 2, 1, 0, instead of going plus 20 to go forward, I'm going to do minus 20 and go backwards. So 130 minus 20 is 110. If I go minus 20 again, 110 minus 20 is 90. And minus 20 one more time is 70. So the initial fee for electrician B is $70. Now we are ready to answer this question. So let's just see here. Electrician A has an initial fee and an hourly rate that are both less than those for electrician B. Well, that's not true because their hourly rate is higher, so A is out. So electrician A has an initial fee and an hourly rate that are both greater. That's not true. Electrician B has a higher initial fee here, so this one is out. So it's going to be one of the last two answer choices. So now choice C, electrician A has an initial fee that is less than that for electrician B. So far, so good. And then the hourly rate for electrician A is greater than that for electrician B. That is also true. So C is our answer, but let's see what's wrong with choice D. Electrician A has an initial fee, which was $50, that is greater than that for electrician B. No, 50 is not greater than 70. So there's the false statement here. C is definitely our answer. Question 9, what is the slope of the line on the coordinate plane that passes through the points 2, 2 and -1, -2? For this question, all we have to do is use the slope formula. The slope formula, we have the slope m equals y2 minus y1 over x2 minus x1. And what we could do is just label these points as x1, y1, x2, y2. It doesn't matter which one you call x1, y1 or x2, y2. So here, let's say I call this one x1, y1, and I call this one x2, y2. The reason why I call this one x1, y1 is because this point is more to the left than this one. If we were to plot this, so we could just see what's going on here, the point -1, -2 would be over here, and the point 2, 2 would be somewhere over here. Okay, so what I'm visualizing here is finding the slope of the line that connects these 2 points. And one thing I want to point out, if this gives somebody a nightmare, I apologize, but my friend Slope Guy here helps us understand what we need to know about slope. So in general, when you have a line with a positive slope, the line is going up. So I could just tell right away that our answer is going to be positive just by how these points connected. A negative sloping line, the line goes down. If the line is vertical, the slope is undefined. And if the line is horizontal, the slope is 0. Okay, so that's Slope Guy. Now, I'm going to go ahead and find the slope, but once again, by drawing this out, you could just see what your answer has to be, like what neighborhood it has to be in. It has to be something positive. So now I'm going to use the formula. Y2, I'm doing 2 minus y1 is -2. Make sure that you write the minus there, okay? Don't leave out the minus. That's going to throw everything off. And then you have x2 is 2 minus x1 is -1. And now we just work this out. If you want to use a calculator for this part, you can, but just know when you subtract negatives, the operation changes to addition. So this becomes 2 plus 2 over 2 plus 1. And now 2 plus 2 is 4 over 2 plus 1 is 3. So our solution is choice D, 4/3. Question 10, a sphere has a radius of 4 inches, a cone has a radius of 3 inches, and a height of 8 inches. Which expression represents the difference in volume in cubic inches between the sphere and the cone? So for this one here, we're going to use the formulas for the volume of a sphere and cone. So the volume of a sphere is 4/3 pi r cubed. Okay, so 4/3 pi r to the third power. And the volume of a cone, I'll just write this off to the side over here. The volume of a cone is 1/3 pi r squared times h. And just know r represents the radius, h represents the height. So if you want to draw this out, you can, just to have a visual. But otherwise, you can just plug right into the formula because they told you everything that you needed to know. They told you the radius of the sphere is 4 inches. And then they told you that the cone has a radius of 3 inches and a height of 8 inches. So everything is just ready to go. So now I'll just plug in. We have 4/3 pi, and then the radius of the sphere is 4 inches. So 4 to the third power is going here. And I'm just going to write it like this because that's how it's appearing in the answer key. Notice that 4 to the third power is entirely inside the parentheses. Now, the difference in volume tells us to subtract. So now this is the volume of the sphere. Okay, so this over here is the volume of the sphere. And we're going to subtract the volume of the sphere with the volume of the cone. Okay, so after this, now we write the volume. So let me just make that a little neater. So the volume of the cone. And we'll see what we get. So the volume of the cone is 1/3 pi, but now we have to just be very careful here. The radius of the cone is 3. So we're going to do 3 to the second power because notice in the formula, r is being squared. And then we multiply by the height of the cone, which is 8 inches. And now we look and we're like, oh no, my answer is not there. And that's because in both of these expressions, there's a common factor of pi. So they're going to factor this out. Okay, they factor out the pi, and then inside the brackets here, we write the leftovers. On the first term, if we divide everything by pi, we're left with 4/3 times 4 to the third power. And now we're going to have minus, with the second part here of the expression, we have a 1/3 left if we factor out the pi. And then we also have a 3² times 8. Okay, so we're just looking for the answer choice that matches this. So let's see. It has to start with 4/3 times 4 to the third power. So that eliminates choices B and D because notice they have a 4 to the second power here. And then minus 1/3 3² times 8. So 3² times 8, this is looking like choice A. The problem with choice C is that the height of the cone, 8, is being squared instead of the 3. So that's why C is no good. A is definitely our answer. Question 12, which value of x makes the equation x to the third equals 64 true? So one thing we have to know here is what does it mean to raise something to the third power? So this question here is really asking you this. They're asking you what number multiplied by itself 3 times equals 64. So if we just go through process of elimination, we could see here that let's say we started at choice B. I know the answer is A, but let's see why the other answer choices are no good. If I did 8 to the third power, 8 to the third power is 8 times 8 times 8. And you could see if you do 8 times 8, 8 times 8 is 64. So if I have to do 64 times 8 now, this is already greater than 64. So that's why choice B can't be the answer. And then if I just increase the value of the thing I'm raising to the third power, this is definitely going to be more than 64, and so is this. Okay, so that's why it's got to be choice A. If we want to verify 4 to the third power is 4 times 4 times 4, and this would work out to, if I do 4 times 4, that's 16, and then I multiply that by 4, and 16 times 4, we could use a calculator, is 64. Okay, so that's why A is definitely our answer. One other thing too, if you wanted to show the algebra, the opposite of raising something to the third power is taking the cube root. So the opposite operation here would be taking the cube root of both sides. And the cube root of 64 is equal to 4. So choice A is our answer. Question 18, the scatter plot below shows the weight in pounds of an alligator as it grows at a zoo. The line y equals 0.3x plus 5.8 has been drawn to best represent the relationship between the alligator's weight and growth time. So here's our graph of the alligator's weight over time. And we want to know here which statement best describes what the number 0.3 in the equation represents in this situation. So let's look at the number 0.3. It shows up in the equation here in front of the x. So let's think about that equation from before, y equals mx plus b. And remember, I said that m, the slope, represents the rate of change. The rate of change. Now, one thing that really helps with questions like this is the concept of slope is that the slope tells you the rate of change, but on a graph, it also tells you the rise over the run. So the reason why I bring this up is that when we want to match it to one of the answer choices, we look at the slope here is 0.3, but the rise over the run is going to help us with the units to find our correct answer. So let's think about the rising axis is the y-axis, and the units are pounds. So 0.3, if I had to put units for this, would be pounds over the run, the x-axis, the units for the x-axis are weeks. Okay, so pounds per week. So now piece all of this together. This tells us that the alligator is gaining weight at a rate of 0.3 pounds per week. That means every week that goes by, the alligator is putting on 0.3 pounds. So now we could start looking for our answer. The starting weight in pounds of the alligator is no good. This would actually be the y-intercept. Okay, the y-intercept here of 5.8, the b value, would tell us how much weight the alligator starts at when they start measuring the alligator's growth. Okay, so A is no good. B, the approximate number of pounds that the alligator gains each week. Well, this one is looking good because notice pounds per week and the number of pounds the alligator gains each week. So choice B looks good. But now why are the other answer choices no good? C is the maximum number of pounds the alligator gains each week. This one here, I know they're saying pounds per week, but remember, if we're using a linear model here to represent the alligator's weight, there's not going to be a maximum number of pounds that the alligator gains each week. We're just looking at the average rate here, okay, that this is going to be a constant rate of change if we're using the line. So that's why C is kind of close, but we're not looking at the maximum because using this equation, the weight is going to be changing by the same amount each week, okay, using this line here, because it's which statement best describes what it represents in the equation. So C is out. D, the average number of pounds of food the alligator is fed each week. This is not the case. They don't even talk about how much food the alligator is fed. So that's why D is out. B is definitely our answer. Question 19, trapezoid ABCD and its image A prime, B prime, C prime, D prime are shown on the coordinate plane below. Which series of transformations could be applied to map trapezoid ABCD onto trapezoid A prime, B prime, C prime, D prime? So here, note that we're starting from this trapezoid. Okay, this one here is where we're starting from, and we want to land here. So when I look at these answer choices, I'm seeing already that these two answer choices are no good, because if you look, if we reflect this trapezoid over the y-axis, so we're going to send it over here on this side, and then we rotate, this is going to send us outside of this quadrant here, okay? The quadrants, we have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. The problem with the last two answer choices is that when we reflect, we're going from quadrant 3 to quadrant 4 if we reflect over the y-axis. But then if we rotate by 180, let's say, if I'm in quadrant 4 and I rotate 180, that's going to put me over here because I'm just going half a circle around like this. Okay, so that's why this one is definitely no good. If I reflect over the y-axis, I go from 3 to 4, and if I rotate 90, that would put me in quadrant 1, but I have to land in quadrant 4. So now it's down to choices A and B. If we reflect, let's say I take 1 point here, A, I reflect over the x-axis. So I'm going to go up 1, 2, and then I'm going to go up another 2 like this. Technically, I just went up 4 because the scale is counting by 2s, but if I go up to the x-axis this amount, I'm going the same amount through. So right now that puts the reflection point here, A, to this location over here. We are at negative 10, 4. Okay, so we're at negative 10, 4. And then if I rotate this, let's think about how much would I have to rotate this to get from here to, my goal would be to send this point here to this point here. Well, I would have to rotate 180 degrees through the origin like this, okay? The center of rotation would have to be the origin. I'd have to rotate this 180 degrees to get here. So that's how I know this is going to be choice A. Choice B is no good because if I only rotate 90 degrees about the origin, that would send me, depends on the direction I go, but if I go 90 degrees this way, it's going to send me in quadrant 1. If I go 90 degrees this way, it's going to put me back in quadrant 3. All right, so that's why choice B is no good. A is definitely our answer. Now, before we move on, a little trick that I want to show you. Let's say you forget the formulas for rotating. And let's say I'm starting out here at this point, negative 10, 4. I just reflected over the x-axis. If I want to rotate 180 degrees, I would just take my paper, and you could do this with your test paper or whatever paper you're using. And if I want to rotate 180, I just flip the paper upside down. And pay attention to where that point went. Notice the point went, if I treat this as the normal x and y axis now, and I start at 0, 0, this would send me to the right 10, down 4. So notice that I land at 10, negative 4, at the location of A prime. So that's how I'm confident that the 180-degree rotation would work. If I only wanted to rotate 90 degrees, so let's say I want to rotate the point negative 10, 4, 90 degrees, and I'm using my center at 0, 0. If I rotate 90 degrees, let's say clockwise, I'm going this way, that would put me back in quadrant 1, and my coordinates would be over here at 4, 10. Okay, if we rotated, let's say 90 degrees counterclockwise, I just turn my paper 190-degree turn to the left, and I would be at negative 4, negative 10 instead. Okay, but just showing you this nice little trick, because if you forget formulas or you want a more visual way of seeing this, that rotating or turning the page works very nicely. Question 20, which equation represents a linear function? So for this one, we're looking for an answer choice that's in the form of y equals mx plus b. And notice if there's no exponent written there, it has to be x to the first power. So looking through all of the answer choices, the only one that's in this form is choice A. The problem with choice B is that this is a quadratic equation. It's in the form of x squared plus 5. So this would be a parabola. This is another one that has an x to the second power. So this is another parabola. And then y equals 1/5 x to the third power is a cubic equation. Okay, it has a power 3 in it. So this is not linear. Choice A is our answer. Question 22, on a coordinate plane, triangle ABC is rotated 90 degrees clockwise about the origin and then dilated with a scale factor of 2, centered at the origin to form triangle A prime, B prime, C prime. Which statement describes the relationship between triangle ABC and triangle A prime, B prime, C prime? Okay, let's pay attention to the two transformations. First, triangle ABC is rotated 90 degrees. If you rotate a triangle, that does not change the size or shape of a triangle. Okay, so rotating has no effect on the original triangle. It just changes the direction that it's facing, but the two triangles would be congruent. However, the moment you dilate with a scale factor other than 1, and it doesn't matter where your center of rotation is, the new triangle is not going to be congruent to the original. So let's just see, if I have something like this, let's say my center is over here. When I dilate a triangle using this, let's say the center over here, and I have a scale factor of 2. The scale factor of 2, what it does, and I'll just use this straight line feature like this. I'm just going to draw this in like this. So I'm going to draw straight lines from the center to all 3 points of the triangle. What happens when you dilate is you're going to either make the triangle bigger or smaller. So in this case here, if I have a scale factor of 2, what I'm basically doing is I'm doubling the distance from the center to each of those points. So I'm going to eyeball it and say this would be my next point. And I'll change colors here so that it really pops out. So we're going to say the new point would be here. Going along this line, I'm going to double this distance. So I'll put this point over here. And then this one will be a little bit trickier, but I'm going to double this one. I'll say it's going about here. But you could see that this new triangle here that I'm going to draw in green, the image of the original triangle, if I dilate with the scale factor of 2, these two triangles are the same shape, but they are a different size. So when two triangles are the same shape, but they are a different size, the word for that is similar. So the two triangles would be similar, but not congruent. And once again, the reason why they are not congruent is because the new triangle is bigger than the original triangle. So if the triangle is bigger, then all of the sides are not going to be the same. The angles are going to match up. Like the corresponding angles, this angle here and this angle here did not change, but the size of the triangle changed. The side lengths doubled. So choice B is our answer. Question 23, one of the angles in a triangle measures x degrees. Another angle in the triangle measures y degrees. Which expression represents the measurement in degrees of the third angle of the triangle? So for this one here, if you could kind of imagine what's going on, we have this triangle, let's say over here, and we're not drawing this necessarily to scale or anything. We're just going to say this angle is x, this angle is y, and we want to find the mystery third angle. Well, we should know that the sum of the three angles of a triangle is 180 degrees. So some students will look at this and say, all right, I'm going to add x and y together, and then I'm going to subtract this from 180. And they go, oh, choice B. But no, choice B is a very dangerous bear trap. We have to be very careful here. When you add these two angles together, you should put them in parentheses. Okay, we're going to have to add x and y and then subtract that sum from 180. So the parentheses here make the world of difference. And if you're like, wait, that doesn't make sense. Well, for these questions, you could always just pick out random numbers to see how it works. Like let's say x was 20 degrees. And let's say y was 30 degrees. So here, if I did 20 plus 30, 20 plus 30 is 50. And if I subtract 50 from 180, so I'm just make that a little bit neater. So I'm going to subtract 50 from 180. The missing angle would be 130. But the problem with this, if I went with choice B, if I did 180 minus 20 and then plus 30, watch what happens as I go from left to right. If I do 180 minus 20 is 160, and then plus 30, that would give me 190, not 180. Okay, so that's why this is no good. Whereas with choice A, if I do 180 minus, and first I add 20 plus 30, I do parentheses first, then I'm doing 180 minus 50, and 180 minus 50 gives us the 130, which is the measure of the missing angle. Okay, so the parentheses will really, really save the day here. Choice A is our answer. Question 27, which expression is equivalent to 3 to the 5th power? So for this question, we should know the exponent rules. We have a to the b divided by a to the c equals a to the b minus c. Anytime you divide two exponent terms that have the same base, what you do is you just keep the base the same and you subtract the exponents. If we had, let's say, a to the b times a to the c, this would work out to a to the b plus c. Once again, we keep the base the same, and in this case, we just add the exponents. And then the third case would be if I have a to the b to the c power. In this case, I would actually multiply to make a to the b c power like this. Okay, but in this question, notice we have all division, so this is the property that we have to use and make sure that we use it right. So choice A, if we apply this rule, you can see this is going to work out to 3. We keep the base the same, and we subtract the exponents. And 10 minus 5 is going to give us 5. So this one is equivalent to 3 to the 5th power. This one is good. So why are the other answer choices wrong? Well, here I could see the misunderstanding. We keep the base the same, but this student might make the mistake of doing 15 divided by 3. But remember, we're not dividing the exponents, we're subtracting. So if we do 15 minus 3, 15 minus 3 is 12. So choice B works out to 3 to the 12th power. All right, so that's why choice B is no good. This one here, the problem is the bases do not match. So this one, we can't just go ahead and use this property. All right, this one is like very advanced if you did want to simplify this. This one, I would have to rewrite 9 to the 10th power as 3 to the 2nd power to the 10th power, and then over 3 to the 5th power. So you see, like 3 to the 2nd makes 9. So I could rewrite this, and then I would use this product property. If I did 2 times 10, I would get 20. So I'd have 3 to the 20th over 3 to the 5th. And then this, I could do 3 to the 20 minus 5, which would give me 3 to the 15th power. Okay, so that's how I know choice C is no good. But in this case here, it looks like they do 9 divided by 3 is 3, and then 10 minus 5. So just, yeah, be careful. C is tempting you to do the wrong thing. And now here, the problem with choice D is this would give us 9 to the 3 minus 5, and that would give us 9 to the 3 minus 5 is negative 2. So here, this is definitely not going to match up with 3 to the 5th power. So D is out. A is definitely our answer. Question 30, which list of numbers could represent the side lengths of a right triangle? For this question, we have to know the Pythagorean theorem. A squared plus B squared equals C squared. When we have a right triangle, any right triangle, the sum of the squares of the two legs has to equal the square of the hypotenuse. Okay, so just know A and B represent legs of the right triangle. The hypotenuse, C, is the biggest side, and it's across from the right angle. Okay, so the hypotenuse has to go opposite of the right angle. So really all we have to do for this one here is plug in the 3 sides into the Pythagorean theorem and see which set of 3 sides actually makes it work. So something like, let's say, choice A is no good. Because if I did 5 squared plus 10 squared, notice I'm plugging in 5 and 10 for A and B, and then I set it equal to C squared, and the hypotenuse, the longest side here, they're going to claim is 13. The problem with this is that when I simplify, 5 times 5 is 25, plus 10 times 10 is 100, equals 13 times 13 is 169. That on the left side, I get 125, and on the right side, I have 169. This is not true. This is not true. So this tells us that A is out. So I really just have to run through all the answer choices until I get something that works. And if I run through them all, B is not going to work. C will work. Okay, if we run choice C through, this is going to work. And the way that I'm able to do this in my head is a nice little trick to have, and you could use this for your future math classes as well, is there are popular right triangles that show up a lot, and we call them Pythagorean triples. The classic one is 3, 4, 5. If I had a 3, 4, 5 right triangle, these three sides would satisfy the Pythagorean theorem. Another popular one is 5, 12, 13. So 5, 12, 13 is another popular Pythagorean triple. And then a few more I'll write over here. The other most common ones here are 8, 15, 17. And then the last one I'll write is 7, 24, 25. And I'm not necessarily drawing these to scale, but these are the most popular Pythagorean triples that you will encounter through 8th grade and high school. But why I like to use the Pythagorean triples is that I look for answer choices that either directly match or that give a triangle that is similar to one of these. So I'm looking at 5, 12, 13, and I say, all right, let me dilate this with a scale factor of 2. What is going to be the new side length of each of these triangle, or of the triangle here? The new side lengths, if I use a scale factor of 2, I'm doing 5 times 2 is 10, 12 times 2 is 24, and 13 times 2 is 26. So I get to see right away that choice C was going to be the answer. Choice D is no good, but once again, if you want to just use Pythagorean theorem and run it through all the answer choices, that works fine. But let's just run it through to double check. So I'm going to do 10 squared. So I'm going to press 10 to the second power like this. Okay, then plus I have 24 to the second power. And we're going to get this value here, 676. If you are using a scientific calculator, another way you could get the squares here is you could just do 26 times 26. So let's say I want to check 26 squared to see if when I plug into the Pythagorean theorem that I get the same thing. I could write 26 squared like this, just 26 times 26. And notice that I get a match. Okay, so we can say here 10 squared plus 24 squared equals 26 squared. So choice C is definitely right. Question 33, the table below represents a function, and we have an XY table here. Which statement describes the function? And for this question, we really just have to determine if this function is linear or nonlinear. Now, just know that if the function is linear, that would be because it has a constant rate of change. So that's something to look out for as we go through this table. So notice the X column here is increasing by 1 each time. To get from 2.5 to 3.5, that we could do by just adding 1. And the same thing, to get from 3.5 to 4.5, we're going up by 1. And now let's pay attention to what's going on in the Y column. To get from 7.5 to 10.5, we're going up by 3. And then to get from 10.5 to 13.5, we're going up by 3. So what this is telling us is that the rate of change here is constant. Okay, the rate of change, we could call here the slope, is going to be 3 over 1, or it's equal to 3. Remember, one of the concepts of slope is rise over run. So we could see that to get from one y value to the next, we're going up by 3, and the x's are going up by 1. If you want to use the slope formula here, you can, but it's much faster to just go ahead and see how much we're increasing by in the y direction and in the x direction here. But if you use this slope formula to find the slope between all of the points, you're going to get 3 each time. So that tells us that this function here is linear, and the reason being is that the rate of change is constant. So the function is linear because the rate of change is constant. These answers are just wrong by default because they're saying nonlinear, but let's see what's wrong with choice C. The function is linear because the y-intercept is a constant value. No, that would just be true for any line, but what makes something linear is the rate of change being constant. The y-intercept being a constant value is also true for, let's say you have a parabola, something like this. Okay, if I just drew out something random like this, and let's say it hits the y-axis at 1, there's a constant y-intercept here, but that's, once again, this is not a linear function. So C is no good. B is definitely our answer. Question 34, quadrilateral FGHJ is rotated about the origin to form quadrilateral F prime, G prime, H prime, J prime. And we want to know which two sides are equal in length. Now, for a question like this, there's a nice little shortcut. When you look at the answer choices, you want to pick two sides that have the same letters. So notice A is out because F matches F prime, but G and J don't match. J matches J, but F doesn't match H, so B is out. And then we have GH, and we have GH here. So this right away I could see is the answer. And then the last one, H matches H, but G and J don't match. So this one is out. But let's just investigate this a little bit more, aside from just the shortcut. So if I look at side GH in this quadrilateral over here, let's see where it's going to land if we're rotating about this point over here at the origin. So when we rotate in this direction, notice that GH is going to land over here at G prime H prime. If I had to find other locations for the other sides, something like, let's say, FG would map to F prime G prime over here as it rotates. And then we could see that, let's say, this side over here at FJ, this would map to F prime J prime over here. Okay, so as we rotate this entire quadrilateral, these are the sides that would correspond. So that's what we're looking for. But remember, the nice shortcut here is that the letters have to match up. If we're going from FGHJ to F prime G prime H prime J prime, then GH would have to map to G prime H prime in the other one. So C is our answer. Question 35, a manufacturer makes cylindrical cans in two sizes. The dimensions of each can are shown in the diagram below, and we want to know what is the difference between the volumes in cubic centimeters of the large can and the small can in terms of pi. So since we're dealing with cylinders, we have to know the formula for the volume of a cylinder, which is pi r squared times h. So this is the formula that we're going to use. And let's go ahead and find the volume of the large can. So the volume of the large can, we're going to have pi times the radius is 3.5. And we have to square it and then multiply by the height of the large can, which is 10. The units I could leave out because the answer choices are all in terms of just numbers. But the volume, if we had to put units at the end, would be cubic centimeters. So this is going to give us the volume of the large can. And in a moment, I'm going to type all of this into the calculator. But I'm just going to set it up first before I type everything in. Now, the volume of the small can, we're going to find using the same formula. So we have pi times the radius squared. But let's be careful here. Notice they gave us the diameter, the distance going all the way across. So to find the radius, I would have to take 7 centimeters and divide it by 2. So the radius would be 3.5 centimeters. Okay, and now from here, I'm just going to plug that into the formula. So I have the radius is 3.5, and it's being squared, and the height of the small can is 6 centimeters. So now I'm going to type these into the calculator and then subtract them. Now, remember, we want our answer in terms of pi, so I'm not going to type pi in. I'm just going to type in the numerical part. So we're doing 3.5 squared. So I could do 3.5 squared like this, or I could just do 3.5 times 3.5. That's fine. So next, I'm going to write times 10. So I'm going to hit times 10. And this is going to give us the coefficient of pi, or the number in front of pi, for the volume of the large can. So the volume of the large can is 122.5 pi. And now for the small can, we're doing 3.5 squared. So 3.5 squared and then times 6. And now ultimately what we're going to do is we're going to do 122.5 pi minus 73.5 pi. So I can just subtract these two numbers here. I'm going to do 122.5 and then minus 73.5. And this is going to give us our coefficient of pi. So let's just write everything out. The volume of the large can is 122.5 times pi. Okay, so I just did the arithmetic in the calculator. And then the volume of the small can, when we did 3.5 squared times 6, we got 73.5. But now I just tack on the pi. But the question was asking for the difference between the volumes. So we have to subtract 122.5 pi minus 73.5 pi. Okay, and just think of this as we are combining like terms. So we just have to subtract 122.5 by 73.5, and we get 49, and then we just tack on the pi. So choice B is our answer. Question 36, an equation is shown below, and we want to know which statement about the equation is true. So for this one, I'm going to start off by using the distributive property. I'm going to distribute the 2, and we have 2 times 3x is 6x, and then we have plus 2 times 1 is 2. And now on the right side, I'm just going to combine like terms. Notice I have an x and a 5x, so I have x plus 5x. The invisible number in front of x, if it's not written, is 1. So I'm really just doing 1 plus 5 is 6. So I have 6x and then plus 1. And now what jumps out at me right away is that my equation, I have matching x terms, but the constant term is different on both sides. So right away, I could see that this is going to be a situation where we have no solutions. If you really want to see why, what we could do is subtract 6x on both sides to start solving this equation. And on the left side, 6x minus 6x cancels. 6x minus 6x cancels on the right side. And we're left with 2 equals 1, which is not true. Okay, so no matter which x value we plug in, we're never going to get something true here because the x's just canceled out completely. Now, the visual concept of what's going on here is if I were to graph these two lines, let's say, and I'm just going to do a sketch here, 6x plus 1, I'm just going to say I'm going to draw something here with a positive slope and a positive y-intercept. And then I draw 6x plus 2. Notice that these two lines have the same slope. Okay, if I have a slope of 6 for both of them, they have the same slope. That would make the two lines parallel, and that would mean the two lines never intersect. And if they never intersect, then they never have a solution common to them. Okay, so that's why choice A is our answer. Question 37, which statement best describes the value of square root 2? So for this question, we could just type right into the calculator. The square root of 2, I'm going to press second x squared to pull up a blank square root, and then press 2. And we're going to get this decimal value here. If you have one of those scientific calculators, you might have to press 2 and then press the square root button. But just know that you're going to be looking for the square root of 2, which is this decimal value here. Now, one thing I want to point out is that square root 2 is an irrational number. It is an infinite decimal, and it does not have a repeating pattern to it. So now what I'll do is I'm just going to sketch the number line, and I'm going to plot this number on the number line. And I'm going to start here at 0, and I'm going to count by ones. But I'm going to leave a lot of space so that I could use the decimal values in between. So I'm going to put 0.5 over here. And then halfway between 1 and 2 is 1.5. Okay, and now let's think about it. 1.41421, and this continuing value is going to land somewhere over here. Okay, this is pretty close to 1.5. So now we could go through the answer choices. A says the number is between 0.5 and 1. But if we look at this space over here, the number is definitely not here. So A is out. Between 1.5 and 2 is incorrect because 1.4 is, and this continuing decimal is less than 1.5. So it's definitely not between these two. So B is out. And now notice that C and D start the same, between 1 and 1.5. But which number is this square root 2 closest to? Is it closer to 1.5 or is it closer to 1? It is definitely closer to 1.5. And the reason being, you could see here that if I counted by tenths, let's say from here to here, I broke this up into 5 pieces. So let's say I went 1, 2, 3, 4, 5 like this. This, let's say I call over here 1.1 and then 1.2, 1.3, and then 1.4. We could see that 1.414 is in this neighborhood here, definitely closer to 1.5. So for this question, you definitely need a little bit of number sense. You have to be able to break up the number line into smaller pieces. But we could see here once again that the 1.4-ish is definitely closer to 1.5 than it is to 1. So choice D is our answer. Question 38, a set of ordered pairs is shown below, and we want to know which ordered pair should be removed to make the set a function. So when you want a set of ordered pairs to be a function, you want to look out for repeating x values. What we want to happen here is we want there to be no repeating x values. Okay, so repeating x values is bad when you're trying to create a function of x. Okay, so no repeating x values. So looking here, notice -3 only shows up once in the x spot. 1 does not repeat, 4 does not repeat, -1. Here's the culprits. So -2, -1, and -2, -3. These points are the problem because notice that -2 shows up twice. So one of these points would have to be removed, and the only one that shows up in the answer key is choice C. But one more thing I want to explore is that you may have learned another way to check to see if a graph is a function, and that would be if the graph passes the vertical line test. Okay, so the vertical line test, the way it works is that when you have a graph of some function, like let's say a parabola, if you draw a vertical line at any location through the graph and the vertical lines only touch at one location, then your graph represents a function. Something like a circle is not a function because if I draw a vertical line, it hits the circle twice. So if I were to plot all of these points, you could see that the 2 points that I circled, -2, -1, and -2, 3, fall on the same vertical axis. If I were to drop down a vertical line through these set of points, notice that the initial vertical line I drew here hits these 2 points that were highlighted. So that's why if we remove -2, -1, if we remove this, then the set of points here, anywhere that I draw a vertical line, is going to pass through those points just once. Okay, so choice C is definitely our answer. Question 39, a movie theater sells popcorn in cone-shaped containers as shown below. And we want to know what is the volume in cubic inches of the popcorn container. And we have to round our answer to the nearest tenth. So for this one, we're going to use volume equals 1/3 pi r squared times h. This is the formula for the volume of a cone. And here we have a radius of 3 inches and a height of 5 inches. But the units we don't have to write because the answer space at the bottom has cubic inches waiting for us. So we're going to write in now the volume equals 1/3 pi times r is equal to 3. So we're doing 3 squared. And then times h is equal to 5. Now, the scientific calculator you're using should be able to handle you typing in everything at once. But if it can't, then just type things in one at a time. So here I'm going to do 1/3 as parentheses 1 divided by 3. And then pi is second, and then this up arrow here, okay? Or just find the pi button on your scientific calculator. And then I'm going to put parentheses 3 squared, and then we have times 5 at the end, so I just put parentheses 5. And press enter, and this gives us the decimal that we need. So now if we look at what the calculator gave us, the tenths place is over here, okay? So here is the tenths place, and we look 1 digit to the right is a 2, so this tells us to round down to 47.1. Okay, so the volume we're going to say is 47.1 cubic inches. If this were instead something like, let's say, 41.153889, and this continued on, then we would look to the right as a 5. We would round up to 47.2. But that was not the case here. Okay, we had a number to the right that was less than 5, so that's why we're rounding down to 47.1. So our solution is 47.1 cubic inches. Question 40, the area of a square-shaped garden is 324 square feet. And we want to know what is the length in feet of each side of the garden. So for this one, if we want to draw this out, we can. So we have a square. And in a square, all of the sides are equal in length. And the formula for the area of a square is the side length squared. So for this one, if they're telling us the actual area is 324 square feet, that's the space on the inside. We're just going to say 324 is equal to s to the second power. And then to solve for s, we could just take the square root of both sides. And that's going to tell us that s is equal to, and now we'll just type in, we have the square root is second x squared. And now we're writing in 324. So s is equal to 18. And the units here, we would say 18 feet. But once again, all of the answer spaces will have the correct units waiting for you. So the answer here is 18 feet. Question 41, line segment AB is graphed on the coordinate plane shown below. And we want to know what is the length in units of line segment AB. So for a question like this, what we want to do is we want to take this line segment and build a right triangle around it. So what I mean by that is I'm going to go from point A straight up, but I'm going to stop when I get to the same height of point B. And then I'm going to go from left to right here. I'm going to go across to get to point B like this. I could have also built my right triangle going this way. It doesn't matter because I'm going to get the same answer either way. So now I have a right triangle and I'm going to count the boxes going across and down. So we're going to go across 1, 2, 3, 4, 5 units. And then we're going down. Let's count here. We're going 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this right triangle, the legs are 5 units long and 12 units long. A nice little shortcut is I don't actually have to count the boxes all the way down. Like let's say I didn't feel like counting to 12. What I could do is just subtract the y values. Notice I'm going from a height of 8 down to a height of -4. So if I did 8 minus -4, that would give me 8 plus 4, which is equal to 12. So that's just a faster way of getting there. The same way I could just do 7 minus 2 is 5 because I'm going from 2 to 7. So now that we have this, we could use the Pythagorean theorem to find the length of line segment AB. So notice here that line segment AB, I could just put an X here, is the hypotenuse now of this right triangle that we just built. So using the Pythagorean theorem, remember we have the formula a squared plus b squared equals c squared. I'm going to do 5 squared plus 12 squared is equal to the hypotenuse squared, which I labeled with an X. Okay, so now I'll just work this out. So we have 5 times 5 is 25, plus 12 times 12 is 144, is equal to x squared. And now if I add these two numbers, I'm going to get 169 equals x squared. And then from here, I just take the square root of both sides. And this is going to tell us that x is equal to the square root of 169 is 13. Okay, so the length of AB is 13 units. And one thing I mentioned before was the Pythagorean triples. And notice that we wound up with a 5, 12, 13 Pythagorean triple. Okay, so once again, that's one of the popular ones. But the Pythagorean theorem is a nice way to show that the length of AB is 13 units. Question 42, in the figure below, line P is parallel to line Q, and lines AD and AF are transversals. What is the measure in degrees of angle BAC? Angle BAC is this angle over here. And if you have trouble identifying angles when they're lettered like this, just know that you could just trace out the path to get from B to A to C. If I start at B and then I go to A and then I go from A to C, notice that it highlights this angle up here. So that's just how you'd be able to identify the angle if you were unsure. And now the next thing to focus on is that lines P and Q are parallel. And anytime you have two parallel lines and they are cut by a transversal, the corresponding angles formed are congruent. So if I have a 110 degree angle in this section and it's in the top left spot, then in this section over here, these four angles, I could label this angle over here as 110 degrees. And then I could use that same concept over here. When I have these two parallel lines cut by transversal AF, the corresponding angles formed are also congruent. So the 105 degree angle in this top right spot, I could also say that the top right angle over here is also 105 degrees. And now one of the next big ideas that we could use is that on a straight line, the angles make 180 degrees. So this angle over here, if I just put an X for a moment, X plus 110 would make 180. So if I want to find the value of X, I could just do 180 minus 110. And that's going to tell me the measure of one of the missing angles here is 70 degrees. Okay, so I have a 70 degree angle over here. And now I could use that same concept over here. If this angle is 105 and I do 180 minus 105, that's going to give me 75, which is going to tell me the measure of this angle over here. This angle is 75 degrees. And now to find the measure of this missing angle inside of the triangle, what I'm going to do is I'm going to add 70 and 75. So I'll do 75 plus 70. And I'm going to subtract this sum from 180. Okay, so we have 5 plus 0 is 5. 7 plus 7 is 14. And I'm going to subtract 145 from 180 because the three interior angles of any triangle will add up to 180 degrees. Okay, so that's how we're going to find the measure of this angle over here. So now I'll go ahead and do the long subtraction. We could use a calculator, but I'll just practice long subtraction. 10 minus 5 is 5. 7 minus 4 is 3. So the missing angle BAC is 35 degrees. Okay, so I'm just going to write that down here. The missing angle is 35 degrees. Question 43, the equation y equals 1.5x plus 29 is used to model the yearly salary y of an employee in thousands of dollars, where x is the number of years the employee has worked for the company. What does the slope of the line represent in this situation? So for this question, we're using the formula y equals mx plus b. And if we were just graphing a line, m is the slope and b is the y-intercept. But in word problems, m is the rate of change. Okay, that's the rate. And b is the fixed amount. Okay, so if we look at this question here, we're talking about somebody's salary. The rate of change would represent their raise each year. And the fixed amount is the amount that they started at. What was their starting salary? So if we just throw some numbers into this, let's say I threw in x equals 0, just to gain some intuition as to what's going on here. If I plugged in x equals 0, I would get y equals 1.5 times 0 and then plus 29. And this would tell us that your starting salary here is $29. No, that would be very depressing. You have to read these questions very carefully. The y value is in thousands of dollars. Okay, so your starting salary at this company is $29,000 a year. Okay, so that's why it helps to throw some numbers in just to get a sense of what's going on. If you were to throw x equals 1 into the equation, then you'd have y equals 1.5 times 1 plus 29. And if I did 29 plus 1.5, that would be 30.5. So after 1 year, your salary is now $30,500. So I like to just do a little bit of investigating because then that helps you explain your answer. What does the slope represent? The rate of change, that tells us the raise that we get each year at this company. So as 1 year goes by, we get a $1,500 raise per year. Okay, just know that the math that you could do in your head or type in the calculator, the 1.5, we're talking about thousands of dollars. So we're really doing 1.5 times 1,000 because it has to match the context. And that's $1,500. Okay, so we're getting a $1,500 raise each year that we're at this company. Question 44, a dog owner collected data to see which of his 2 dogs run at the greater speed. The graph in the table below show the relationship between the time in seconds and the distance in feet each dog ran. And we want to know what is the difference in feet per second between the speeds of the 2 dogs. So for dog A, we have a table of values. And if we look at the X column, we could see that to get from each value to the next, we're going up by 2. If we do 2 plus 2, we get 4. 4 plus 2, we get 6. And 6 plus 2 brings us to 8. And if we look at the y values, the mystery number that we're adding to everything is 56. If I did 56 plus 56, that brings me here. And if I just keep adding 56, I'm going to get the next values. So that tells us that we have a constant rate of change. So this is a linear table. And then looking at dog B, we could see that this graph is showing us a straight line. So if we're talking about the speeds of the 2 dogs, the speed is how much distance they cover over time. So let's take a entry from the table first for dog A. So it takes the dog 2 seconds to cover 56 feet. So for dog A, I'm going to show the work over here. Dog A goes 56 feet in 2 seconds. Okay, so 56 feet in 2 seconds. So if we divide 56 divided by 2 is 28. So that tells us dog A, the dog speed is 28 feet per second. Okay, so every second that goes by, this dog covers 28 feet. For dog B, it's a little bit trickier, but not too bad. What I would do here is find a nice point on the line. They gave us this point over here at 8,200, but we could also go with this point over here. This point lands exactly on one of the corners at 4,100. Okay, so this point will work just fine. So the x-axis is telling us how much time goes by in seconds, and the y-axis is telling us how much distance is covered in feet. Okay, notice that we're starting at 0, 0 here because the dog is, starting off here covering no distance at all, and then that's when the distance is being recorded. So this is at 0, 0. But what we're basically finding here is the slope of the line formed by connecting all of these points. So let's go ahead and find the slope of this line. And for this one here, we could use the formula for slope, y2 minus y1 over x2 minus x1. And I could find the slope between any 2 points on the line, but using 0, 0 is the easiest way to go. So I'm going to use this as our point, and I'll use this point because the numbers are smaller. So now dog B, if we just do the subtraction here, that's 100 minus 0. I'm doing y2 minus y1 over x2 minus x1. And the units for the y values is feet. And for the x that we're subtracting on bottom, the units is seconds. And if I do 100 divided by 4, that's 25. Okay, so dog B is running at a speed of 25 feet per second. But the question is asking us to find the difference, okay, the difference in the speeds of the 2 dogs. So here we're going to do 28 minus 25, which is equal to 3. Okay, I'm not going to write the units here because the answer that we're writing over here has the unit attached feet per second. So the difference between the speeds of the two dogs is 3 feet per second. Question 45, two ordered pairs of a linear function are shown below, and we want to know what is the rate of change for the function. So just know that rate of change means slope when you're talking about a linear function. So we're going to find the slope between these 2 points. So I'll call the first point x1, y1, and I'll call the second point x2, y2. And from here, we're going to use the slope formula m equals y2 minus y1 over x2 minus x1. So now just plug into the formula. We have y2 is 5 1/4, and we're subtracting 4 1/2. And then we're going to divide by the difference of the x values. I'm doing x2 minus x1. So let's use the calculator for this. Now, one thing I want to point out is that 5 1/4 is the same thing as 5 plus 1/4. You'll see that we're going to get 5.25. 1/4 is equal to 0.25. So when you want to write mixed numbers, you could write the whole number plus the fraction. It's equivalent to this mixed number over here. So what I'm going to do is I'm going to have 5 plus 1/4, and I'm subtracting 4 1/2. So when I write minus 4 1/2, I have to make sure to write 4 1/2 in parentheses. So 4 plus 1/2. If you just know that 4 1/2 is 4.5, then I would honestly just do that. And that'll give you your answer to this question very quickly. Okay, like let's say I want to do 5 1/4 is 5.25 and subtract 4.5 for 4 1/2. That's going to give me the exact same answer. Okay, so we're going to get 0.75. So now I'll just write this out. We have m equals, we said 5 1/4 minus 4 1/2 is 0.75, and we're dividing by 3 minus 2 is 1. So the slope works out to 0.75. So we could write our answer as 0.75, or we could write it as a fraction, 3/4. But either way, we would get full credit. So I'm just going to write the decimal value. Our answer is 0.75. Question 46, what value of x makes the equation shown below true? And we have to show our work. So for this question, we're going to have to use the distributive property to start solving for x. So we're going to distribute the 1/4. And one thing that might be challenging is dealing with the fractions. So one thing you want to keep in mind when you're doing these, when you're multiplying 1/4 by 3x, just know what you're really multiplying is the coefficients. So you're doing 1/4 times 3. And when you multiply a fraction by a whole number, you could just do the numerator times the whole number. So we're going to get 3 on top, and the denominator just stays the same. The reason behind this is I could just call 3/1. So this would work out to, I could say 1 times 3. I'm multiplying the numerators, and then I multiply the denominators. So like this, and then 1 times 3 is 3, 4 times 1 is 4. So this starts off 3/4 times x, and then minus, if I do 1/4 times -8, well, I'm going to have my minus here because I'm doing a positive times a negative, but I'm really just doing 1/4 times 8. And for this one, what I'm thinking is just 8 divided by 4 is 2, and then 1 times 2 is 2. So I'm going to have minus 2. And I don't distribute the 1/4 all the way here because I have to stop where the parentheses stop. So that plus 4 at the end is just going to get tacked on. And now this one's easier because I'm distributing a whole number. And I'm doing 2 times x is 2x. And then 2 times -4 is minus 8. Okay, so now this is getting a little bit simpler. So here we could just combine like terms. We're going to have 3/4 x. And then -2 plus 4 makes positive 2. And this is equal to 2x and then minus 8. And now from here, what I would do is I would move the smaller x term to the other x term. So notice 3/4 is less than 2. So I would rather subtract 3/4 x on both sides than subtract 2x on both sides. So I'm going to do this, minus 3/4 x. Okay, and from here, let's say you want to use the calculator for this. You can. What you could do is you could say 3/4 is equal to 0.75. And if you do 2x minus 3/4 x, you could just do this in the calculator, 2 minus 0.75, and that would give you 1.25. So you can do it this way. That's fine. Or if you want to make common denominators, you can make common denominators. If you want to show the work on the side here, just do 2 minus 3/4, you could call this 2 over 1 and then find common denominators. And that's going to give you 8 over 4 minus 3 over 4. And 8 over 4 minus 3 over 4 makes 5 over 4, which is still equal to 1.25. All right, so that's just some math. You have options here. You could do this or you could do this. So these will cancel out. Now I have 2 equals. And let's say I go with the fraction. 2x minus 3/4 x makes 5/4 times x. And then we have minus 8. And now to solve for x, I just have 2 more steps. I'm going to do plus 8 on both sides to get rid of this minus 8. And then I'll divide in the last step. So now minus 8 plus 8 cancels. 2 plus 8 is 10. And this is equal to 5 over 4 times x. And now to solve for x, to get rid of times 5/4, I'm just going to divide both sides by 5/4. Okay, if you want to use the calculator for this, just do 10 divided by 1.25. You can, but we could also show the work here by working out the fraction. So I have 10 times, I'm using keep, change, flip here. So I'm keeping the top, I'm changing the operation to multiplication, and I'm flipping the bottom to 4/5. And when I work this out here, 10 times 4/5 is equal to 8. If I want to show the work by hand, 10 divided by 5 is 2, and 2 times 4 is 8. So our x value here, we could say x is equal to 8. Question 47, a list of numbers is shown below, and we have to classify each number as either rational or irrational, and we have to be sure to include how you know a number is rational, and we have to explain our answer. So for this one here, if we just investigate these numbers, we could see which one is rational or irrational. Square root of 49 is equal to 7, and all whole numbers are rational. Now, if you want a formal definition for rational numbers, a number is rational if it could be expressed in the form a over b, where a and b are integers. So a and b are integers. And also, there's one extra requirement here. So and b cannot be 0, because you can't divide by 0. Okay, so this is what qualifies a number as a rational number. And just in case you're not sure, what I mean by integers, the integers are the whole numbers, including 0 and the negatives. So that would be 0, 1, 2, 3, and if I just keep counting this way, and also if I count backwards, -1, -2, -3, and so on. Okay, so this is the set of integers. So for this, if I look at something like 7, I could say 7 divided by 1, and 7 and 1 are both integers. So this is definitely rational. 1.3 repeating is a rational number because it's an infinite decimal that has a pattern to it. If I really wanted to do some more investigating, I could express 1.3 repeating as 4 over 3, and then you see how it falls into this category here of what it means for a number to be rational. I'm going to save this one for last because this one is irrational. And the way that I know it's irrational is anytime you take the square root of a non-perfect square, you're going to get an irrational number. Just know the perfect squares are, I'll write them over here, 1, 4, that's 2 times 2, 3 times 3 is 9, 16, 25, 36. You can see how 32 falls between 25 and 36 in our list of perfect squares. So that's how I know we're not taking the square root of a perfect square, and therefore we're going to get an irrational number. And then 7 over 2 is equal to 3.5, but I could also just say here that it's in fraction form. 7 and 2 are integers, so that's how I know this is rational. And then 1.234, this I could express as 1234 over 1,000. So there it is again. Any terminating decimal can be expressed as a fraction where your numerator and denominator are whole numbers or integers like this. So that's why these numbers are all rational except for the square root of 32. But when we are writing our argument, we can just say that we have a terminating decimal. That's another way of arguing why something is rational. Now, before we move on, there's just one more thing I want to point out about the square root of 32. If we type in the square root of 32, notice that the decimal we get this infinite decimal, and there's no clear pattern to it. There's no repeating pattern. So another way to write our argument as to why square root of 32 is irrational is we could say that it's an infinite decimal that has no repeating pattern to it. Question 48, store A and store B sell fabric for different prices. The equation y equals 3.5x represents the price y in dollars for x yards of fabric at store A. And the graph below represents the price for the same type of fabric at store B. And we want to know what is the unit rate for the price of fabric per yard at each store. And then we want to know how much more would the price of 9 yards of fabric be at store A than at store B. So once again, we're using the formula y equals mx plus b. And remember, m represents the rate of change. This is telling us in the context of this question how much it costs for fabric, the price per length in yards. So here, if we look at store A, so store A, they gave us the equation for the total price was y equals 3.5x. This tells us that the store A rate, if we look here, is $3.50. So the rate, we could say, is $3.50 per yard. Okay, we're just using the units that they gave us here. We're talking the y value is the price in dollars, and the x value is the length in yards. So we could just write that over here, that it's going to be $3.50 per yard of fabric. So notice I have the dollar sign here to match the units that we need. And now for store B, if we want to find the rate, we're going to actually have to find the slope between the 2 points here. Now I could use these 2 points, or I could use the origin, because notice this is coming from 0, 0, which makes sense because if you buy no fabric, you're going to pay $0. But let's say here that I use the 2 points that they gave us. So I'm going to call this x1, y1, and I'm going to call this x2, y2. So for store B, I'm going to use the formula y2. We'll just make that a little bit neater. So we're going to use y2 minus y1 over x2 minus x1. And now I just plug in. The slope is going to be 16.5 minus 5.5 divided by 6 minus 2. So the slope, if I do 16.5 minus 5.5, that's going to give us 11 divided by 4. And if we do 11 divided by 4, this we could just type into a calculator. That's going to give us 2.75. So now I just write that in store B's location over here. Store B, they charge $2.75 per yard of fabric. So now the last stage of this question is how much more would the price of 9 yards of fabric at store A be than it is at store B? So for 9 yards, let's say I do store A. So store A, I'll write this over here. I'm going to do $3.50 per yard. I'm going to multiply that by 9 yards. Okay, so it's $3.50 per yard. So we're going to multiply that by 9. Let's just fix that here. So $3.50 times 9, and we'll just work this out. $3.50 times 9 is going to give us $31.50. Okay, that you could just type in a calculator. So store A, it's going to cost $31.50 for 9 yards. All right, so this is, I'll just say over here that this is for 9 yards. Let me just fix this so that it looks nice. So this is for 9 yards. And now for store B, we're going to use the rate that we found for store B. If we were to multiply 275 by 9, this will work out to, we're going to see here, this works out to $24.75. Okay, so $24.75. All right, so that's how this one is working out. So I'll just write this over here so that it matches exactly how it looks over here. So this is also for 9 yards. And now what we want to find here is the difference. So for the difference, now we just have to subtract the two. So we're going to do $31.50, and we are subtracting $24.75. And if we do the subtraction, this, we could just type in the calculator, is going to work out to $6.75. So here's our solution to the last question.